So you are an AI architect or AI engineer or a software engineer that is trying to build some kind of agentic system. And you are confused whether or not you even need an agent at all, whether you need to create just a single agent or if this is a multi-agent scenario. Well, if you have faced this dilemma before, this particular video is for you, because in this video, we're going to be talking about some of the selection criteria and some of the decision metrics that we use to figure out which strategy we should use when writing this type of systems. So in the first scenario, you may not even need an agent at all, meaning there is no large language model or small language model involved in the application. There are some scenarios where you just need to create a single agent, and there are some scenarios where you have to have an orchestrator or sometimes multiple orchestrators that are routing requests and some of the tasks to different sub-agents, which we call a multi-agent scenario. So that is what this particular video is about. If you've been facing this particular challenge, this video is for you. So stay tuned, because we're going to be uncovering some of the different decision points that will help us decide which strategy to go with. So some of the common engineering mistakes that beginners or people that may not really have the experience with this is that they decide to, instead of just connecting to a database to create records, to retrieve data, to update and to modify or maybe sometimes delete records from the database, they decide to use an agent to do this. So simple CRUD operations. CRUD means create, retrieve, update, and delete. So if you have this scenario in your application and it's very straightforward, you know exactly what you want to create, exactly what you want to retrieve or modify or delete. In such scenarios, no large language model is even needed to make that decision, because if you give it to something that is probabilistic or stochastic, like a large language model, you might end up with a scenario where it makes a mistake and it misunderstands what you're trying to ask it to do, and it ends up making the wrong choice. So in that kind of scenario, you don't really need a large language model. And there are some scenarios where you might need to, instead of having to parse the text and look for keywords and create all kind of complex regular expressions, in that kind of scenario, you might need to use a language model to route the requests. And in this scenario, just one simple task that you are trying to accomplish. So something like that would be much better suited for a single agent scenario. Now, there are some scenarios where you might need, let's say maybe we have a particular task that is, if you inspect it, it has some subcomponents. For example, planning a vacation might involve booking a hotel, it might involve getting a car rental, it might involve booking flights, booking activities for theme parks, for cruise ships, and things like that. So you can see how you would need to have sub-agents that are specialists in each of these different subtasks that are part of the overall objective of going to the vacation. So in such scenarios, it is best to split it up into different sub-agents and have a multi-agent scenario. So I'm going to do a deep dive into each of these scenarios now, and we'll take a look at when we need no agent, when we need just one agent, and when we would need to break it up to have an orchestrator agent and multiple sub-agents to handle the different responsibilities. So in the first scenario, where we don't need any large language model, meaning this is not an agentic need or strategy, if you have something that is very clear, that if the input is 1, and this is the action. If the input is 2, this is the action. So if you have something like a switch statement or an if, like a branching condition, if else, or if else, if, and things like that, when it is very clear that a particular input maps to a specific output, in that kind of scenario, there is no need to risk it and give it to a large language model. So that is very, very clear, particularly in scenarios maybe when you are giving an input from a form field where you have a drop down and the values are very discrete and you don't have to guess. So such scenarios require you to just route it using typical branching strategies in programming languages like Python, C#, Java, TypeScript, JavaScript, and so on. So that kind of scenario, you don't really need to use a large language model. If also you don't have the need to invoke any tools, then there's no need to bring in a large language model. In scenarios where the response time and the speed is very, very sensitive, so you have very low latency requirements, in such scenario also using a large language model should not be encouraged. So that scenario does not require any agent. If you also are very sensitive to confusion or ambiguity, so when you don't want any kind of misinterpretation or any kind of ambiguous output, then such scenario requires rule-based systems that are routed to either through switch statements, through maps, through if-else conditions and things like that. So such scenarios require you to use no agent at all. And you don't need a large language model to bring in reasoning and things like that. So this is a scenario where if you have this in your code, no agent could be required, and you don't have to worry about that. Now let's move to the criteria. So this here summarizes it. If you can write the unit test to cover and map every input to every output, then language model is not needed, so no agent required. Or if also you cannot tolerate any kind of randomness, any kind of stochastic or probabilistic output, then you don't want to gamble. In such scenarios, try to avoid using an agent, and you will be good. So that's the summary of some of the decision points that we can use to decide whether to go with single agent or no agent at all. Now, when we need a single agent is when we have to parse the input text or the input stream. It could be a video, it could be a picture, it could be something like plain text. So if you have that kind of scenario, then you definitely need a large language model that is capable of consuming the input and then figuring out what to do. If you need to consume that input token and then decide to invoke a tool, then in that kind of scenario, you definitely need a large language model. If also you can tolerate randomness or probabilistic output or stochastic outputs, then that kind of scenario can support the use of a single agent. So meaning that you are fine with bringing in a small or large language model to analyze the input and then give a response based on the input that you have decided to call. So that is the scenarios in which we can use a single agent. In this case, we just have to address one single task, not too many confusing things. So this is the architecture. You have a system prompt that kind of guides the language model as to what to do. You may or may not have tool definitions that will give this language model the capability of taking actions or bringing in context or creating records or modifying records. So in that kind of scenario, using a large language model is good, and we are able to just create a loop, receive the input, and then decide what tools to call or what to do with the input, and then the output is routed back to the user, and we are comfortable with that. So that is the summary of when to go with a single agent. The first thing that you have to make sure is that you are comfortable with giving something that is based on probability. So if you're not comfortable with that, then you have to go back to the single agent strategy. So we just receive the input, make sure that it complies with the system prompt that we have given the model. If any tools are involved, we invoke it. If not, we just get back the answer from the language model and give it back. So that is the summary of the single agent. Now, There are scenarios, like I mentioned earlier, where we have a task and some kind of objective that we are trying to accomplish, but this objective requires us to reach out to specialist agents to handle the subcomponents of the overall task. So in this kind of scenario, you will need to have one or more orchestrators that will be able to receive the input and then break up the task into multiple subtasks, assign each of the tasks to a specific sub-agent. These agents can work in sequence, they can work in parallel, and they can bring back the response back to the orchestrator, who now puts it together and then sometimes verify it before giving it to the user. So if you have that kind of scenario, then definitely you need to bring in a multi-agent design and make this happen. Also, another thing to consider is that when there are certain scenarios where we have a context window that is kind of small. Sometimes you may see context windows that are 200 tokens, and we cannot just, like in our travel agent scenario, put all the tools for the flight agent, the hotel agent, the cruise line agent, the car rental agent, all these different tools into one single language model connection, and then expect it to not hallucinate, expect it to be not distracted, and all those different things. So when you have that kind of scenario where we have limited context window to work with, and it will be better if we have specialized language model connections as agents that will handle these different subtasks. That scenario really calls for a multi-agent setup. So set up the orchestrator, decide what are the tasks that are going to be involved in this particular request, break it up into the different sub-agents, and then configure each sub-agent to have their own tool set and their own limited system instructions. This will allow you to have higher quality output from the sub-agents, and you can package and combine the results from each of the different sub-agents into the original request. So if you have that kind of scenario, then definitely you need to have a multi-agent scenario. Also, it's also good if we need to bring in a human in the loop. Sometimes it's better to have that as a multi-agent so that you can have some kind of checkpoint agent that would interface with the human, and then whatever response is given, that response is routed back into the request and then to any of the other sub-agents that should handle the finishing out the request. So that is the high level description of the multi-agent scenario. And obviously, when you break things up like this, it allows you to run them in parallel, if that is possible. There may be sometimes scenarios where the output of one agent becomes the input of another agent, so that might make it not possible for you to run them in parallel. So you may have to do it sequentially, but the main benefit of doing this is that it allows you to, number one, narrow down the scope of tools that are being assigned to the language model, to the agent. It also allows you to limit the system prompt and make it very specific. And this reduces distractions, also called hallucinations, that makes the agent to give you random output that you don't really expect. So that is when we need to use the multi-agent scenario. So this is the design for that kind of scenario. You have the main agent, the supervisor or orchestrator agent that breaks up the different input tasks based on the input, gives it to the different sub-agents, and then collates the output from each agent and gives a particular response. So that is the high-level overview of this particular agent. Now, just to summarize again before we round up, if you have a scenario where you cannot really tolerate randomness or any kind of probability-based output, then definitely go with no agent. So don't involve a large language model. If this is fine, then you can go with a single agent. And then if you have to do things that are parallel, if you have the need to break up the task into multiple subtasks so that it can fit in the context window, or you can run it concurrently or in parallel or simultaneously, then you can decide to go with the multi-agent setup, where you have different agents that have limited set of tools, limited system prompts, and very intense focus on the specific tasks that they have to do, and that will help you to accomplish a much different performance. And sometimes with these multi-agent systems, it allows you to pick and choose which language models you should use, because sometimes the language model might require vision, it might require more advanced reasoning depending on what it's supposed to do. For simple lookups that speed is required, you may just use something that is simple, like maybe a mini version of the language model instead of going with the super version of the language model. So this helps you to manage latency, manage quality of output, manage performance, and manage the financial cost of running these large language models when you have the multi-agent setup. So this is the breakdown of everything that allows you to understand what scenario to go with. So if we want to use agents for work that is deterministic, one of the problems is that you might run into latency, you might bring in the risk of the agent hallucinating. So in that scenario, it's just better to just write very straightforward code and avoid using a large language model. And sometimes people might decide to go with multi-agents when just a simple agent can be sufficient. So in such scenarios, try to avoid that. If you also have a context window that is limited, it is good for us to break up the task into multiple sub-agents so that we don't crowd the context window. We allow room for the agent to be able to keep track of multiple histories and be able to perform appropriately. Also, avoiding a human in the loop is something that most developers do. So we should try to avoid that, because particularly in the multi-agent scenario, it is always good, if you're not really sure about something, bring in the human so that we can address the different scenario that is involved, and then a human will be able to make a decision that can be used as input for the remainder of the sequence of the task that we have to accomplish. So that was everything that we had to cover. This slide here just summarizes all the different scenarios that you consider when going between complexity and the need for reasoning and the need for being flexible. So if complexity is very high and the need for reasoning is very low, then you go with no agent. Now, if the complexity is low and the need for reasoning is also low, then we can go with a single agent. And as you see here, when the need for reasoning becomes higher while the complexity stays low, then we can go with the multi-agent. So this here is a summary, and it will help you to decide when to go with single agent, when to go with no agent, and when to go with multiple agents. So that's what I had to share today with you. I'm gonna have this cheat sheet in the description, so you can download this and use it in your team meetings, use it in your planning, use it in your own consultation with your colleagues or customers or clients or partners or whoever you are interacting with. One of the takeaways that I will have to give you is everything I've been saying so far. This 3-question framework will allow you to pick between no agent, a single agent, and multiple agents. So not everything requires an agent. Try and keep things simple if you can, because it will help you control the cost, control the performance, and control the user experience that the agent is presenting. So that's everything I have. If you want to do a deep dive into any of these topics, please put it as a comment in the video, and I will definitely respond back to your question, or if I need to do a deeper dive, then I will do that. But I think for now, this is everything that you need to decide between no agents, between going with a single agent and doing the multi-agent setup. Thank you very much for your time and your attention, and I will see you in the next video.